Let's continue our discussion of methods by looking at two methods. One that converts a Fahrenheit temperature into a Celsius temperature, and another that takes a Celsius temperature and turns it into a Fahrenheit temperature. We'll develop those one at a time and test them as we go to make sure that they're working correctly. So we begin our definition of a method below or above main. I'm going to do mine below. We'll skip a space here. So we start out with the keyword static. The return type of the value we're returning from the function, we'll make that double. And we're going to call this one F to C to go from Fahrenheit to Celsius. And it will take a double temperature as its parameter. To perform the conversion, and we can do this again as a one-line program, but just to show the difference, I'll do it in a couple of lines. So let's start out by declaring a Celsius temperature, double Celsius. And then we're going to say Celsius is equal to, and the conversion factor is the temp, which will be a Fahrenheit temperature, minus 32 degrees times 5.0 divided by 9.0. All right, so notice how I use parentheses to make sure that the correct sub-expressions are computed first, and then we're going to return the Celsius temperature. And that's all I have to write for my function. So let's test the function. Let's prompt the user to enter a temperature. So I've imported the scanner class. So we'll create a scanner object first. One system in. Then we'll create a double Fahrenheit temperature and a double Celsius temperature variable. And then we'll say system out print enter a temperature in Fahrenheit. And ftemp is equal to input dot next double. And then we'll say ctemp is equal to F to C ftemp. So ftemp becomes our argument that matches the parameter, both in number and in data type. So we have one parameter, so we have one argument. Our parameter is double, as is our argument. And then we can print out the result or display the result. So we'll write system out.println ftemp f is equal to, oops, I left out a plus sign right there for concatenation, ctemp c, close parenthesis and semicolon. I believe that's all we need to test this. So let's save the file. Then we'll compile it. Javac chap 10 part 2.java. Left off a semicolon right there. Okay. Again, following my policy to never hide my own errors. So we fix it. Let's compile again. There we go. So we'll do something we know. 32 Fahrenheit should be 0 Celsius. 32.0 F is equal to 0.0 C. Let's try one more. 212 Fahrenheit, that's boiling point, should be equal to 100 Celsius. And it is. So we have the Fahrenheit to Celsius function working correctly. And this is a very good example of a typical function where we want to perform some named task, Fahrenheit to Celsius, that we don't want to clutter up in the main program. I haven't really talked much about this reason for methods yet. But one of the things you want to do when you're writing your programs is keep your main program as small as possible, as easy to read, and as clear as possible. And one way to do that is to take as many possible computations out of main and put them into methods. So that's what we're doing here. Rather than having this code in our main program, we put it up in main. What that does, besides cleaning up our code, is lets the reader of the program decide for themselves whether they want to go through the task of understanding what F to C does. If they don't care, then they can just skip it. If they do care, they can find the method definition and read how it works. So now let's write a Celsius to Fahrenheit function also. So we'll start off static double, this is C to F, double temp, double Fahrenheit as our variable, and then we're going to write Fahrenheit is equal to, and the conversion function for that is the temperature, the Celsius temperature, times 9.0 divided by 5.0 plus 32 degrees. I started off with the parenthesis there. We don't really need that. The one parenthesis we need is we need this division to happen before this multiplication. So we do need those parentheses there. That's the only set we need. And then we're going to return the Fahrenheit value. And we'll talk a little bit more about returns in a second. We close the body. Let's comment out this code just because I don't want to have to create a new scanner object, and I need one if I'm going to be inputting multiple versions. Plus, I don't want to run that code again anyway. So here we're going to say system out print, enter a temperature in Celsius. ctemp is equal to input dot next double, and then we'll write ftemp is equal to c to f ctemp. There's the function call, and again with the correct argument, and then we'll write system out print line ctemp plus c is equal to ftemp plus f, semicolon to end the statement. All right, looks right. We can fix it if it's not. Let's compile. Let's clear the screen first. Compile. Whoops, there we go. That's just a little typo. Print. Save. Clear the screen. Try it again. There we go. Cap 10 part 2. So 0 Celsius should be 32 Fahrenheit. Let's run it again. And 100 Celsius should be 212 Fahrenheit. I just use boiling and freezing points as easy numbers to test. Let's review again a method definition. We start out with the keyword static to indicate that this is not part of a class. There's another meaning for static inside classes. We'll look at that later in the course. Then we have the return type of the function, followed by the function name, followed by the parameter list. In this case, it's just one parameter, a temperature. Then we open the method body, then we perform the task, and then finally, all value returning methods have to have a return statement where the value that the method computed is returned to the calling program. So that's what we have, where we have return Celsius, or in the example of C to F, return Fahrenheit. And then we close off the body of the method with a closing curly brace. And then the method call is where we want the method to perform its computation, and we can put that any place an expression is expected. So in this case, we're putting it on the right-hand side of a assignment statement, here and here. And then the data passed into the method call is called the argument, and we have to make sure that that argument matches the parameter in data type and in number, so that if we have more than one parameter in our parameter list, we have to have an equal number of arguments in the argument list in the method call. So there's another good example of how methods are written. What I want to do in the next lesson is look at a couple of method calls where we have more than one parameter. And in fact, we'll start out with an example from this Fahrenheit and Celsius conversion example that we're looking at right here. And we'll do that in the next lesson.